Hey there, happy Friday. It's May 15th, and we're going to take chapter 10.3 notes today. Here's the warm-up. It says a number cube is rolled. Determine the probability of each event. So I want to give you the list of possible outcomes. On a number cube, just like a regular dice, you would roll. The possible outcomes are going to be 1, 2, 3, 4, 5, and 6. So give this warm-up a shot and unpause when you're ready. Here we go. So the probability of rolling a 5 is like getting a 5, like there's only one 5, so the number of 5s over the total. So there's only one 5 on this cube and there are 6 options, so the probability is 1 over 6. The probability of rolling an even is the number of evens on the cube over the total. So 2 is even, 4 is even, and 6 is even. 3 of the outcomes are even out of the 6 total, but you can reduce that, so I'm going to write a half. What about number 3? Rolling a 3 or a 4. The probability of rolling a 3 or a 4. So number of 3s or 4s over the total. There's 1 3 and 1 4, so there are 2 favorable outcomes out of the 6 total. But you can reduce that to 1/3. Rolling a 6, there's 1 6 out of 6 total outcomes. Rolling a 1 5 or a 6. So there's 1 1, there's 1 5, there's 1 6, there's 3 favorable outcomes out of the 6 total, but I can reduce that to 1/2. Rolling an odd number. 1, 3, and 5 are odd. There are 3 favorable outcomes out of the 6 total. Again, reduce. All right, here's our essential question for 10.3. How can you use relative frequencies to find probabilities? Pause the video, write down your essential question, and we'll move on. So here's the first key idea. Everything we did in 10.2 was called theoretical probability. We didn't actually roll a number cube. We didn't actually spin a spinner. We theorized about it. We made hypotheses about it. We didn't actually perform the experiment. That's called theoretical probability. And the entire warm-up was that, where we didn't actually roll the number cube. We just theorized about the probability of the outcomes. There's another kind. It's called experimental probability. And the probability fraction is still the same. The number of times the event occurs over the total number of trials that you perform the experiment. And this is something where they actually performed the experiment and recorded the results. So someone actually rolls a number cube, or they physically spin a spinner and record the probability of the event. Let's try an example. Now this is printed in your notes, but it doesn't tell you how many times they rolled the number cube, but it says it right here. So somebody, not us, sat there and rolled a number cube 50 times and recorded the results in this table. It says, what is the experimental probability of rolling an odd number? Now, if we talked about the theoretical probability, we know how to do that. There are 3 odd numbers out of 6 total. So there's 1/2 probability in theory that you'll roll an odd number. So it's about 50-50 chance that you'll roll an odd. But let's talk about experimental. Probability of getting an odd is a fraction, right? Still a fraction. The number of times they rolled odd over the total number of times they rolled. Total number of times they rolled that dice. So we want to look at our chart. Well, 1 is odd, 3 is odd, and 5 is odd. They rolled a 1 10 times. They rolled a 3 8 times. And they rolled a 5 11 times. We need to know how many times did they roll an odd number. So we need to add them. They rolled an odd 29 times. And they rolled that number cube 50 times total. So now we have our fraction. Can you reduce the fraction? Use that multi-chart. See if you can find 29 and 50 in the same row or column, and then you'll know if you can reduce it. You can't, really. There's no number that goes into 29. It's prime. But we can sort of see that this half of 50 is 25. So this is really close to a half. It's really close to the theory that rolling an odd theoretically is a half, or equally likely as not likely. So the experimental probability is very close. Let's try another one. Here's another one. They rolled the number cube. Somebody rolled it 300 times and recorded these results right here. And they told you the numbers at the top so you don't have to look at that tiny graph. It says, what is the experimental probability of rolling an odd number? Try this example. The total is 300 times, and then the rolling of odds. Try these examples right here, and unpause when you're ready. Okay, so rolling odd. 1 is odd, 3 is odd, and 5 is odd. How many times did they roll an odd? 48 times for a 1, 50 for 3, 49 for 5, and I'm adding. Feel free to use a calculator there, and when you add it up, you're going to get 147. Excuse me. It says, what is the experimental probability of rolling an odd? Well, the probability of getting an odd is the number of times they got odd over the total rolls. Okay, so they got odd 147 times, and someone rolled that number cube 300 times. Now we need to decide if we can reduce that. And you can use a calculator to guess and check your work. Start with 2 and then go up with 3, and 3 does go into 147, and 3 goes into 300. And when I divide that, I got 49 out of 100. Now let's talk about part B. This is 49 out of 100. That's really, really close to a half. And if we think about the comparison between theoretical probability and experimental probability, they are really close in this case. They rolled that number cube so many times that the experimental probability almost perfectly lines up with the theoretical probability, which is really great because that shows that our experiment is well calibrated to the theoretical possibility that we'll roll an odd number. So summarize those notes. Make sure you practice this one. Practice it a few times. Try the homework. And if you're struggling at all, please, please, please come to office hours. I'm here to help you. I want to help you. Or send me an email if you're not comfortable with that. I can help you via email too. Anyway, I'll see you guys next week. Bye.